When we last talked about inverse functions, we were talking about something that reverses the rule of a function. So an inverse function we found by solving for the input. So the input becomes the output becomes the input. With sine graphs, in order to have an inverse function, the function has to be 1-to-1. Well, we know by the horizontal line test that the sine function, its inverse, would not be a function because the horizontal line test says if you draw a horizontal line through the graph, it never hits the curve in more than one location. It's kind of like the vertical line test. But the horizontal line test tells me that its inverse won't be a function. So in order to actually create an inverse function, we're going to restrict the domain. And what we're going to actually restrict the domain to is we're going to restrict the domain to between negative pi over 2 and pi over 2. And there's a reason we're restricting it to that particular interval. We'll talk about that in a minute. So, if all I do is restrict myself, to this part of the curve, from negative pi over 2 to pi over 2, then I actually can find its inverse. The inverse will be this graph. And notice how the pi over 2 and the negative pi over 2 are now graphed on the y-axis, where your negative half, negative 1, negative 1/2, 1/2, 1, 1.5 are now graphed on the x-axis. We also call, there are two ways of representing the inverse sine. One of them is this notation, which is called arc sine. The other way of representing it is like this. Now, the -1 there, sometimes we see the -1 and we want to think that it means reciprocal, because when we give you something like x to the negative first, that's the same thing as 1 over x. Well, in this case, this is just the notation. It's the same as when we did this. It was pronounced f inverse of x. It didn't tell us to actually do the reciprocal. And now what I want you to notice is the domain of our arc sine is from -1 to 1, where the domain of our sine function, in order to find an inverse, needed to be between negative pi over 2 and pi over 2. We had learned that there were these inverse properties that when utilized on one another would cancel each other, kind of like natural log and the exponential function e. They would cancel each other. Well, sine and inverse sine do cancel each other under certain conditions. If you're taking the sine of the inverse sine of x, they cancel for the domain from -1 to 1. The reason is because this is really your input, and its domain was -1 to 1. And then the inverse sine of the sine of x will equal x for the domain negative pi over 2 to pi over 2, because this is really the input and its domain was negative pi over 2 to pi over 2. So in our first example, we're going to find some inverse sine functions. Now, I'm going to approach this a couple different ways. To find the inverse sine of 1/2, this is the same thing as saying the sine of x equals 1/2. However, I want to remind you that we had a restriction on our inverse sine, and the restriction was that our inputs had to be between pi over 2 and negative pi over 2. If you were to do this on your calculator, because you'll notice that the second function above the sine key says inverse sine, the graphing calculator will always give you an answer between pi over 2 and negative pi over 2. Those are called principal values. So I know that whatever the answer is, it has to be an angle in the first quadrant or in the fourth quadrant. Now, let's talk about our all students take calculus. Sines are not positive in the fourth quadrant. They're only positive in quadrant 1. So I know that whatever my angle is, it's going to be in quadrant 1. Well, which angle had a sine of 1/2? You can do your hand trick. You can take out your unit circle, and you're going to find out that it is the 30-degree angle, which is pi over 6. And that angle falls under our restricted domain. Let's do this again. How about the inverse sine of -1/2? All right, we have a restriction. The restriction is that the answer has to be between pi over 2 and negative pi over 2. That means that the answer is either in quadrant 1 or in quadrant 4. Well, since sines are only negative in quadrant 4, that means my answer is going to be negative pi over 6. Now we know negative pi over 6 is coterminal with 330 degrees, which is 11 pi over 6, but we're not going to worry about that. We're going to work with principal values, what the graphing calculator would give us if we were to do the problem in that. Let's do one more. Let's find the inverse sine of 3/2. Let's go back a second to the picture of our arc sine. Remember that the inverse sine was between -1 and 1. So now if I'm dealing with a problem that's 3/2, which is 1.5, that's outside of my restricted inverse domain, and therefore it's not defined. In example 2, we're actually going to use our graphing calculator to find some approximate values. Now, we usually need to tell you what mode we're working in. Because we're working with the sine graphs, and the sine graphs we normally graph in radians, make sure that the mode on your calculator is in radians and not degrees. And then just plug into your calculator second sine 0.82, and you should get approximately 0.96141. And if you put into your calculator second sine 1/3, you should get approximately 0.33984. Just a reminder before we do example 3. When we're working in inverse sine, we're restricted to the interval between pi over 2 and negative pi over 2. That means we're restricted to quadrants 1 and 4. Keep that in mind when we find each value here, because the problem is not as simple as a cancellation property for both of these. Now, the first one, the inverse sine of the sine of pi over 3. Well, where's pi over 3 located? Well, it's in quadrant 1. Well, then that's fine. The answer must be pi over 3. Now, if you check it on your calculator, you'll get pi over 3. Now, remember, your calculator doesn't give you pi radians. It always gives you decimal radians. So one of the things you can do is you can change your calculator back to degree mode and instead put in 60 degrees, and it'll tell you that the inverse sine of the sine of 60 degrees is 60 degrees. But 2 pi over 3 is in quadrant 2. So we need to find out where the angle we're going to get is going to be located. Now, remember on the coordinate plane that sines are positive in both quadrant 1 and quadrant 2. So if 2 pi over 3 is in quadrant 2, the answer has to be positive. Therefore, the answer we're looking for must be in quadrant 1. Well, what's the reference angle? The reference angle is pi over 3. So the inverse sine of the sine of 2 pi over 3 is actually going to be pi over 3, because our answers have to be restricted to quadrants 1 or 4. So in other words, If the angle you're given would result in a positive answer, you're going to be working in quadrant 1. But if the angle you're given would result in a negative answer, then you would be working in quadrant 4. And you just need to know the reference angles. Now let's talk about the cosine graph and its inverse. We know by looking at the cosine graph that it is not 1-to-1. Therefore, we have to restrict the domain. But how can we restrict the domain so that the horizontal line test will give me an inverse? Well, for cosine, we can't use negative pi over 2 to pi over 2, because if I use this, the horizontal line test doesn't hold true. So we're instead going to use 0 to pi. I didn't do a very good job of drawing that line. There we go. So we're going to use just this part of the function. So that it's, let's see, I'll do this, 0 to pi. So its inverse will look like this. Notice that the graph, when you do the inverse, the output now goes from 0 to pi, and the input still goes between 1 and negative 1. We denote it by arc cosine, or we write it like this. It also has cancellation properties. The cancellation properties are the cosine, the inverse cosine of x is equal to x if it's on this domain. And then the inverse cosine of the cosine of x is equal to x if it's on this domain. And it has to do with what the input is. Think about order of operations. You would evaluate what's inside the parentheses first. So when we find an inverse cosine, remember that we said we're working with values between 0 and pi. What quadrants are those? Those are quadrants 1 and 2. Now remember that cosine is positive in quadrant 1 and it's negative in quadrant 2. So the inverse cosine of square root of 3 over 2 must be located in quadrant 1 because that's where the answer would be positive. Well, then the next question is, the cosine of what angle is square root of 3 over 2 and located in quadrant 1? Well, if you use your unit circle or the hand trick, you'll know that it is 30 degrees, which is pi over 6, which is in quadrant 1. So now let's go to the inverse cosine of 0. So this says the cosine of what angle is 0? Well, using your unit circle, you figure out real fast that it's pi over 2. Remember that the answer has to be between 0 and pi, because there is another angle whose cosine is 0. It's 3 pi over 2, but that's not in our domain. Now let's go to C, the inverse cosine of 5 over 7. Well, 5 over 7 is not it's not the answer to one of our special angles. All the answers to our special angles are square root of 3 over 2 and 1/2 and 1 and 0 and square root of 3 over 3 and square root of 3. So if this isn't one of our special answers, then the only way to do this problem is to do it in our calculator. So remembering that we want to be in radian mode, just do second cosine 5 over 7, and you'll find out the answer is 0.77519. In example 5, let's find each value. Now remember, with the cancellation properties, this only works for angles between 0 and pi. So if you have something outside of that, we're going to have to find a reference angle. So the cosine of 2 pi over 3. 2 pi over 3 is in quadrant 2. That means that it's already in my 0 to pi range. So I can just cancel cosine and inverse cosine, and the answer must be 2 pi over 3. However, 5 pi over 3 is actually in quadrant 3. So let's think about this for a second. Is the angle that's in quadrant 3 here, positive or negative if you're taking its cosine? Well, when you do your all students take calculus, you find out that cosines are negative here in quadrant 3. The only other place where cosines are negative that actually falls in our domain is in quadrant 2. So the angle I'm looking for must be in quadrant 2. And it must have the same reference angle as 5 pi over 3. Well, the reference angle is pi over 3. The angle in quadrant 2 with a reference angle of pi over 3 is 2 pi over 3. Now, another way that you can do this is you could have changed these back into degrees and done this in your calculator, in which case it would tell you the right answer in degrees. The problem with radians is it's going to give you decimal radians. Here was the tangent graph. In order to do an inverse tangent, similar to what we were doing with sine and cosine, the horizontal line test does not hold true if we look at the entire domain. So we're going to restrict the domain. Well, if I restrict the domain to just between negative pi over 2 and pi over 2, and I just look at one little swoosh of this tangent curve, then I'll be able to find the inverse tangent, also known as the arctan. Notice that when we do the inverse, that the output goes from pi over 2 to negative pi over 2, just like the input we restricted to pi over 2 to negative pi over 2. Not only can we call this arctan, but we can also call it inverse tangent. So now let's do the same thing we did with sine and cosine. Let's find each value for an inverse tangent. All right, here's my reminder. My answers are going to be between pi over 2 and negative pi over 2. That means that my answers must occur in either quadrant 1 or quadrant 4. So the first one, remember, this is the same thing as saying the tangent of what angle is 1. Well, using your unit circle, you'll find out that pi over 4's tangent is 1. And since that 1 is positive 1, it must be in quadrant 1, so the answer is going to be pi over 4. The next one, the tangent of what angle is the square root of 3? Well, the angle whose tangent is square root of 3 is pi over 3. And since it's positive, I need my first quadrant angle, and this is in the first quadrant. The inverse tangent of 20. Well, 20 is not one of my special answers, is it? So the only way to do this problem is to do it in my calculator. So you do just inverse tangent of 20, and you'll find out it's approximately negative 1.52084. For posterity, I now will introduce to you secant, the inverse of secant, cosecant, cotangent. So here was our secant curve. Looks like a bunch of little parabolas opening up and down. In order to get a full cycle of the curve and have it not, well, or in order to get the horizontal line test to work, we're going to restrict the domain on secant. We're going to go from 0 to pi over 2, and this is going to seem kind of weird. We're going to go from pi to 3 pi over 2. Not something that you need to remember, but here is the graph, although I guess this graph looks like they actually used this from 0 to pi over 2 and then pi over 2 to pi, and because there's an asymptote between the curves, the asymptote remains in the arcsecant. This picture is different from the one in the textbook. I think I kind of like this one better. Here is cosecant and arc cosecant. They restricted the domain from between, looks like 0 to pi over 2 and 0 to negative pi over 2. And the last one is cotangent and arc cotangent. They restricted their domain from between negative pi over 2 to 0 and 0 to pi over 2. I don't know why they didn't restrict it from 0 to pi. I guess we just want to make sure that the horizontal line test holds true. We don't usually do a lot with the arc cotangent, arc secant, and arc cosecant. We do most of our work with arc sine, arc cosine, and arc tangent.